Hi, everyone, and welcome to Grid Dialogues, our flagship podcast where we explore ideas, innovations, and strategies shaping the future of utilities. My name is Sudeep, and I am your host today. This podcast is brought to you by Grid, a platform helping electric, water, and gas utilities maximize the value of their smart metering and operational data. You can find the links to our LinkedIn and website in the description below. In today's episode, we are going to talk about unlocking DER potential, fixing the integration bottlenecks in modern utilities. Joining me to discuss this is Mr. Pradeep Mishra. Pradeep is a technology leader specializing in DER interconnection and utility system integrations. As a founder at Aurion Systems, he helps distribution operators, CIOs, and energy retailers overcome integration bottlenecks across AMI, DERMS, SCADA, and other market platforms. His expertise lies in building scalable, standards aligned solutions that enable faster and compliant DER rollouts. Pradeep, welcome to Grid Dialogues. How are you doing today?
I am very good, Sudeep. Thanks so much. It's really my pleasure to be here with you, Sudeep.
Thank you so much, Pradeep. So, to start off, can you share a little bit about your journey and what drove you to working towards utilities and innovations, focusing on DER maybe?
Yeah, I think it's very interesting point for me to cover as well. First of all, I'll start with how my journey began with utilities, and not just utilities. Utilities happened quite later in my career or in my professional journey than integrations. So I started up as an integration expert. I would rather say as an integration engineer in my early days when I started my career. It was never about the data or the information. It has always been about the context that usually gets missed in between about the data. Then the ownership of that data itself, like who wants to own. It's not a question of who wants, but rather who should own. So the business generally don't keep focus on who should own, the data, who should own the process and accountabilities. So things get left behind. And the third thing and the most important is the architectural alignment. So coming from technology background, I really do respect people who build sound architectures because that enable the outcomes for the business. And it's not just a technical thing. It's more of a cultural thing. It's more of the hand holding and the coordination and orchestration thing. So that is where I come from, Sudeep. And as we know, we are at the center of decarbonization. Our dear clients and our industry partners are at the midst of that whole storm of DR, and which started with the AMI at the first hand. And we know that integration nowadays, in fact, everybody knows that it is not just a technology or a skill to have, or not something, an IT problem that has to be solved afterwards. It is rather a strategic capability, I would say. So, are you building and leveraging on that strategic capability or not? So that's where we come from, and my journey has been pretty much.
Great, great. Thank you so much for that. So, my first question to you, Pradeep, today is, everybody's talking about, DER, right? And the
Yeah.
adoption is slowly coming into utilities. A lot of utilities are thinking about it. But from your experience, why does connecting these resources still is such a big challenge today?
That is actually a lot of people are asking as well. Why it has suddenly become a challenge. And it was not sudden. The problem with the DER that happened was, again, it was based on the adoption by any country about the solar, I would say, solar panels and solar rooftops, and how dramatically or exponentially this has actually being accepted by the consumers. And there has been policies, favorable policies for the consumers to install more rooftop solars. Now, few
Hmm.
countries like Australia, they adopted it so, I would say, in such a huge volume that was never anticipated. So
Right.
it was basically the adoption and the benefits that the consumers were getting, because it was the first time that happened that people could actually earn by selling the electricity to the grid. And at the beginning, the export price were really good. So they could really eventually not just negate their consumption, but also make money out of it. So that was the
Hmm.
most powerful value proposition. And that is why DR, growth happened like exponentially. But the challenge
Hmm.
of this DR growth, because now we are talking about not just one sided power flows, but rather reverse power flows as well. And for that, our network operators and their systems were obviously not ready. So now the applications are coming like, left, right, and center, which was not expected. Network was not ready to lend that capacity. Already they have been having lot of legacy systems in place, and I think it's quite understandable because they are at the center of this critical infrastructure thing. So they cannot just adopt any new technology or any new system just because they think that it's right to do. They have to take care of so many variables, like there is market, there is their own set of customers, and then they have their legacy processes. So each system works very well. They work very beautifully. It's just that they work in isolation. They don't talk to each other much, and that has been really one of the biggest bottleneck, because with the reverse power flows, with the constraints, with the type of network constraints that DER has brought into the network, that was never
Hmm.
anticipated, and now we are working actually backwards to address that. So the technology is not a problem. Technology has been built, developed, and adopted by few. To the major operators, it has always been an issue adopting new technology.
Yeah, I think that's a great point. I think coordination, as you mentioned, is definitely a challenge. And speaking of which, it brings me to my next question, which is, there's a lot of talk about these missed handshakes within systems. So, what exactly are these missed handshakes, and why do they really matter, according to you, in utility operations if we see the entire spectrum?
First of all, let's understand the handshake is
Yeah.
just like somebody, let's say myself, I want to install a solar
Hmm.
at my house, or, I have, let's say, I have a commercial building and I want to have a solar panel on my building. Rooftop. I would apply on my network's site. I would go and simply ask them for a connection. Behind the scenes, what happens is this customer request goes into their CRM system. From that CRM system, the planning team has to get notified that is my request eligible to get an approval or not. And what happens generally is once the application enters the CRM, they are hardly seamlessly, I would say, integrated with planning tools like ArcGIS, one of the GIS tool, like any other planning and estimation tool, which most of the planning engineers work on. This is one of the missing handshake. Now, how people generally deal with this, and it's a real situation, and I would say that most of the major utilities have this issue. Once that is done, somebody in the network team, they would export this whole application thing into and their metadata into an Excel sheet, and it will be handed over
Hmm.
to the planning team, and then they will start running their analysis, taking into consideration all the SCADA data. So they will prepare the data island from all different systems, and then they will run all their analysis, all their engineering models to conduct their study basically. So a single application might require multiple weeks of data gathering, study, and planning. A very
Yeah.
simple problem could be solved just by having a right intent, setting things straight, have an interweaving layer, which I call an integration layer, like a central integration layer. And this is what the missed handshakes looks like. And then eventually we end up with all the manual retries because not
Yeah.
not a lot of DR data is flowing through the DERMS system. By the way, DERMS is also quite new. People are still exploring what our DERMS will look like. So it's quite early, but emails,
Hmm.
phone calls, number of customer tickets, they are, some of the symptoms which we kind of see.
you know when systems like it could be metering, it could be grid operations, it could be customer platforms, when all these are not aligned, how does that exactly slow down the entire interconnection process, according to you?
I would say, like all systems are really good. It's just that they hold different truths of the same network. So the problem is this: they capture the truth really beautifully. It's all good. It's just that they all speak differently and they all tell us a different story. For example, AMI knows what the consumption was from the interval perspective, but they never know what the DER configuration is. So a network might know really well about the inverters and all the DR resources that consumers might install, but they hardly know what's happening at the meter, why it's capturing those events. So they don't know.
Yeah, yeah, and it is always a blind spot. I totally agree. Yeah.
Yeah, and that's why I say with a common integration layer having in place, we avoid all those fractures. I call them fractures, like process fractures.
That's actually a very good keyword to use, a fracture. Yeah.
And this is where the value
Correct.
realization gap exists, really.
Hmm.
Because there is immense value in all this data that's getting kept. That's already there. Like we don't need to do anything new.
Correct.
We don't need
Correct.
to reinvent anything. It's just what's already captured. The problem is we always try to outsource who wants to think about this problem, like who wants to solve it, instead of
Hmm.
setting the right intent, like what exactly you want to solve.
Yeah, I agree. And uh, a lot of utilities still are dependent on manual, steps when it comes to having these interconnection workflows. So, how much of a challenge is about technology, and how much is about internal processes and the ways of working to do these workflows?
There's also an automation that's has been stressed a lot in all these years. Like let's automate everything, whatever we have. The problem with that approach is we automate failures also very fast. If the process in itself is not hitting the right KPIs, then what we are saying is we are failing fast, which is good, because then you understand that there are gaps in the process. But then thing is, let's get the process right the first time, and then automate things. It has never been about tools not existing to automate the process. It was always about what process actually we are automating and what is it that we are automating. For example, there in the DR interconnection workflow, there is a lot of validations and a lot of studies that happens behind the scenes, which in future is going to be reduced quite a lot, given that there are a lot of innovations going on wherein we can leverage on all the network data, the A by state, the feedback data, and the GIS thing and all other data sets, and conduct a lot of automated studies. But then when we say automated studies, there is percentage of studies that can be automated, but then there are 30 to 40% of studies that cannot be automated, depending on the state or the connection point where connection is required. And so what that brings me to is it requires manual steps, yes, but it's not that everything has to be done manually. Automation can be done, obviously, but then we need to very specifically and very critically choose what to automate. And that requires a cultural shift, Sudeep.
Oh, yes.
That is something that I always say that we have to shift our mindset from technology to
Hmm.
product and a platform kind of a mindset. So because these comes with the ownership.
Yeah.
So we don't need to do project delivery. We rather need to bend, or invest in building the platform capability,
Yeah.
the product kind of a mindset, and not to deal with the siloed KPIs around these, processes, but rather have an end-to-end defined ownership, like who owns it, who is accountable to it. We call it RACI as a matrix, like
Yeah. Yeah.
RACI. So that is, I think it is very much followed as a standard, but hardly it gets implemented. Only used when escalation has to happen. But
That's true.
yeah,
No, I think that's you're very spot on, because unless there is a cultural shift that they really want to make this happen, implement this kind of product, it's never going to you know the cycle is never going to rather get completed, and that's for sure.
true.
Otherwise, it's just a lot of discussions, a lot of talks, a lot of attempts, and as you correctly said, faster failures, uh,
Yeah.
but results won't be seen. Absolutely. So now, if I ask you, how do you see the entire DR interconnection landscape evolving in the next maybe 10 years? And what role will smart integration play, in building really resilient and customer trusted utilities? What's your take on it?
I think the future I see is the DRs, especially in Australia, and now there is another thing is DR in Australia is being treated as like a consumer resources. When I say consumer, it's like somewhere in between 5 to 10 kilowatt inverters and those kind of resources. In US, they treat DER as differently, so they call it grid DER, like they want to have
Yeah.
it clearly specified, and every geography has different naming to it. Eventually, how I see it is, and what I learned from my peers is that in the future, all these resources are going to be treated as dispatchable network infrastructure. So when I say dispatchable, it means grid can dispatch or allow them to have a near real time limits applied on these resources. So they no more remain just a consumer side of resources, but rather providing the stability and the control in near real time, so that actually the entire grid behaves in a coordinated fashion. In order to achieve that state, what is required is the near real time approvals or the results of the interconnections. It requires a coordinated action across all the market layers around the generation and the consumption side of data, and we are saying reverse power flows here at the grid level. So the transmission and distribution, they all need to have a coordinated action. And I think Australia is doing very well in that direction as such. I'm not saying other countries are not doing it. Other countries are doing really well too. It's just that we are all at a very early stage in terms of seeing this DER explosion and managing it and sailing through it. So three states are very important in this. One is how quickly we can act on the applications, the new applications, and how seamlessly we can optimize the dispatch to all
Yes.
these resources and how stable we can be when we are operating these resources. So it will be
Great.
more of the orchestration of the distributed flexibility, because this is all flexibility.
Hmm. Yes.
So
Yes.
we are saying we want to orchestrate this flexibility into our network,
Hmm.
and DSOs will be at the center of it. That's all. That's how I see it. In the coming time. Yeah. So that is what I see as a future. Not sure if you agree with that, Sudeep.
No,
What you have
absolutely.
seen.
I think you're spot on. I really see that this is how the future would shape when it comes to DAR. But
Mm.
thank you so much for shedding so much light in depth. And which brings me to my sort of final question. That overall, I think you explained this process with so simplification. So, anything else that you would like to share in today's episode with our audience about DAR, about interconnection?
I think last two things I would like to touch upon. So whoever is listening, if somebody is into leadership position or governing a program around the DER or flexible exports in any area. So there are five key things which I generally, talk about. The first thing is clearly have the ownership, own the end-to-end process. That will bring a lot of clarity of
Right.
what and why we need to do certain thing. So right from the application, if I talk about the example of DR interconnection, right from the point where the application is being, received to commissioning that DER or that inverter gets commissioned or a rooftop cooler gets commissioned, to its operation, like how it's getting operated, whether the dispatches are going fine or not, what the telemetry is saying, how it's behaving with the network state, and all those things. So this is a process. So have that ownership clearly defined. That brings clarity on what's happening. And
Great.
the most important thing I say is have a reference architecture. Don't let vendors control your reference architecture. So it is
Yes.
something that
Absolutely.
your business stands on, and it has to be directly linked with their capability model, because our clients should own the capability they need to evolve and grow. So control your reference architecture, standardize the data and identity that you have. It's very important because they are in critical infrastructure landscape. Have a clear standard about the data that their systems work on. Having a central integration layer, that is a game changing thing. So if somebody can, if they can invest on building this integration layer out of their existing landscape, not point to point integrations. People are very fond of doing point to point integrations. They are good, they are required at some point, but to leverage the real value from the data that we have, we need to think of building this common integration layer and access that value realization gap, because that is exactly where that value is logged. Let's unlock it.
Yeah.
I say that integration or DER in itself, it's not a technology problem. It's actually a system alignment problem.
Okay.
And why it is a system alignment problem? It's because we are actually working with dozens of systems and processes which are legacy,
Hmm.
and they all speak truth. It's just that story is different.
Right.
And that is why the integration has to be an intentional, architectural, and operationally owned initiative or an approach. Once we treat it that way, once we treat integration that way, DR no longer becomes a bottleneck. It will become an enabler. So, with the right intent, with the right architecture, and owning the operation with clarity, that is going to be bringing the scale and control as we go ahead and scale the DR. So that becomes a backbone basically for the modern grid.
Absolutely. Great. Thank you so much, Pradeep, for joining us today. It was a great pleasure to have you on the show. For all our viewers, do let us know in the comment section if you enjoyed today's discussion and if you would like to have us chat about any specific topic, we'd be happy to cover it. All right. So that's it from today's episode from Grid Dialogues. Thank you so much, Pradeep, again for your time. Really appreciate it. And to all our viewers, see you next time.